In this question, 3-point charges plus Q each are kept at the vertices A, B, and C of an equilateral triangle of side A. So A, B, C, equal charges plus Q. Side of the triangle is A, all the three sides. Determine the magnitude and sign of the charge to be kept at midpoint of BC. Midpoint of BC is D. So that charges at the vertex, charge at the vertex remain in equilibrium. So that net force on A has to be 0. A experiences a repulsive force due to B outward. A experience another repulsive force due to C, again outward. These forces are respectively force on A due to B and force on A due to C. The distance between the points A and B, A and C are same. Charge at A, charge at B, charge at A, charge at C same. That means the force on A due to B and force on A due to C, magnitudes remain the same. That you can calculate as K, which is 1 by 4 pi epsilon 0. Charge 1 Q, charge 2 Q, so Q square by A square. The angle between these two forces 60 degree, equilateral triangle, the angle will be 60 degree. Since the two forces are equal, the angle is 60 degree. We have learned the resultant force will be √3 times of one of the force by vector addition rule. So FAB plus FAC, when you add these two, the resultant will be upward. That will be equal to √3 times of KQ square by A square. The resultant will be vertically up. Now, if charge at D is placed to cancel that force, there should be a downward force on A due to D. So you need to find AD for calculating that force. So if this triangle ADP is taken, 60 degree, sine 60 is opposite side AD by hypotenuse AB. Our aim is to find AD. So AD is equal to AB times of sine 60. So AB length is given as A, sine 60 is √3 by 2. So A into √3 by 2. So we know the value of AD. Now we can find the force on A due to D. That's again K. Charge 1 is Q. Charge 2 we don't know. We call it as Q at D, QD by AD square. AD square will be A √3 by 2 the whole square. So FAD equal to K, charge at Q, charge Q, Q at D by AD square. If you square it, A square 3 by 4 will go on the top. So for KQ QD by 3A square, the force supposed to be down. Force to be downward with this positive charge, the charge at D has to be a negative charge. So we got the sign of the charge at D. The sign of the charge at D has to be negative, so that the other two repulsion is cancelled by an attraction downward. So D has to be negative. Now for finding the magnitude, the net upward force on A due to C and B has to be cancelled by the downward force on A due to D. That means FAC plus FAB magnitude has to be equal to FAD. We can substitute FAB plus FAC. FAB plus FAC is root 3 KQ square by S square. FAD is 4 KQ into QD by 3S square. K get cancelled, 1 Q get cancelled, S square get cancelled. 3 will go to the left, 4 will come down. So 3 root 3 by 4 into Q. That will be the magnitude of charge at D. We already decided it has to be negative charge for equilibrium. So including the sign and the magnitude, the charge at D has to be negative charge 3 root 3 by 4 times of the charge at any one of the vertex.